Hello and welcome. Well, you made it. If you've gotten to this video fractions part 2, then that likely means that you've finished the gargantuanly large video fractions part 1, which was about 2 hours long. I realized that was a long time to get through a video. I'll try to make it so that future videos aren't nearly as long as that. But please understand that part of the reason why some of the videos are so long is because I make sure that I go through each problem step by step, methodically, through each possible step, so that there's no possibility of losing track. Nothing edited, nothing withheld, nothing glossed over, and so nobody left behind. If you're finding that you're getting a little bored with how long the videos are, perhaps you can actually try to change the playback speed of the video. If you hover your cursor over the video, there's usually a small icon, probably right below me, that it looks like a gear, and if you click on that, then one of the options that pops up is the capability of playing the video at perhaps a faster speed, up to twice as fast as normal speed. So keep that in mind as you're going through some of these videos here. But first I'm going to have you start off with some warm-up problems from last time. First I'm going to have you find the greatest common factor and the least common multiple of 18 and 40. Second, I'm going to have you multiply the fractions 5/8 and 4/3. And lastly, find out which one is greater, which fraction, 7/16 or 1/2. Take some time to do that now. Welcome back. Well, when comparing numbers 18 and 40, the only common factor that they have is 2. So 2 goes into 18, 2 goes into 40. It's the only number greater than 1 that actually goes into 40, and so it is also the greatest common factor. The least common multiple is found by taking all of the factors put together, but counting the common one only once. 2 times 2 times 2 times 3 times 3 times 5, or 240. 18 goes into 240, 40 goes into 240. It's the smallest number which both 18 and 40 go into. Secondly, multiplying those fractions, 5 times 4 on the top equals 20. 8 times 3 on the bottom gives you 24, which can be reduced to 5/6. There's also a factor of 4 that you could early on cancel out with the 4 and the 8, which would get you immediately to 5/6 when you multiply over. So either way, that gets you to 5/6. For number 3, which is greater, 7/16 or 1/2, well, the least common multiple of 2 and 16 is in fact 16, and so that's your common denominator to work with. 7/16 is already there, but in order to get 1/2 to 16ths, you have to multiply top and bottom by 8, giving you 8/16. 7/16 is smaller than 8/16, and so 7/16 is smaller than 1/2. So let's actually take a minute for ourselves to get focused, to clear our thoughts, and to get fully in the present moment. Welcome back. The process of adding fraction is pretty straightforward when you are able to visualize the pieces of pie or pizza associated with each one of these fractions here. 3/10 and 4/10 you can visualize here. And since we have the same common denominator of 10, which with each one of these you can actually visualize these two pieces of pie being brought together into 7/10. Similarly, you can see the same thing here with pizzas that are divided up into fifths. You can see 2/5 visualized here, 1/5 visualized here. If you put them together, you have 3/5. So start to figure out what's the pattern here on how you add fractions. 5/6, we can visualize it that way. 5/8, we can visualize it that way. 6/8, we can visualize it that way. If we add those together, we actually get something greater than 1, either a mixed number or an improper fraction. The improper fraction will be 11/8, the mixed number being 1 and 3/8. Once again, see if you can discern what the pattern is. How do we add fractions? Let's take a look at some of the patterns that we've seen here. 3/10 plus 4/10 equals 7/10. 2/5 plus 1/5 equals 3/5. 5/8 plus 6/8 equals 11/8. And ask yourself the question, what would 12/17 plus 3/17 equal? Well, hopefully you can see that the denominator remains the same, and we simply add the tops. 12/17 plus 3/17 is simply 15/17. So once again, if we were to take a look at these examples here, 13/24 plus 6/24, what's that? Again, we're just adding the tops here to get 19/24, and on the bottom, 2/9 plus 2/9, that adds together to give us 4/9. And so in the upper right, how would we symbolize this? How would we describe this algebraically in a form that always works? Always, always, always. If we've got two fractions with the same denominator c, but one is a over c, the other is b over c, you can see from what we've seen before that the denominator of our resulting fraction is still going to be c, but on top we're going to have those two things added together, a plus b all over c. So take a moment to add these fractions together, 5/17 and 4/17, and on the bottom 5/16 and 6/16. Take a moment for that. Welcome back. We can see that for the top fractions, 5/17 plus 4/17 equals 9/17, and on the bottom, 5/16 plus 6/16 equals 11/16. In both instances, we're simply adding the numbers on top. We are adding the numerators. But what do we do when we have denominators that are different? Here we have 2/3 and we have 1/6. And once again, I'm showing you pictures of what each one of these fractions represents. 2/3 above it and 1/6 above that. But what if I could take each one of those thirds and divide them further into 6? You'll see that I haven't actually changed the quantity. We're still seeing basically 2/3 of the pizza there, but represented differently here. Not as 2/3, but as 4/6. It's the same quantity. Once again, remember, all I did was double the top and bottom, really. But now I have something that actually I can add with the other fraction here. 4/6 plus 1/6 equals 5/6. So there's an extra dance step that's involved in adding fractions that have different denominators. You have to go through some processes to make the denominators the same. So let's also take note of the fact that sometimes when you're adding these fractions, you'll see some canceling that needs to take place afterwards, and also you might be converting things from improper fractions to mixed numbers here. We can see this example here on top, 3/8 plus 1/8, that's 4/8, but we know we can reduce that, dividing top and bottom by 4, or separating out a factor of 4 on top and bottom to cancel those. We can reduce the fraction to 1/2. In the same way, we can take 3/16 and 7/8. Well, we need at this time a common denominator, which in this case will be 16, the least common multiple of 16 and 8. 3/16 is already there. We don't need to change it at all. But 7/8 we need to change to 16ths, and we can do that by doubling the top and the bottom, so that it's no longer 7/8 but 14/16. From there, we can add the numerators just like we would if we had started off with two fractions with the same denominator. 3 plus 14 is 17/16. That's an improper fraction, which we can convert to a mixed number just by dividing the top by the bottom. The answer is 1 with 1 remaining. 1 and 1/16. So take some time to do these two fraction additions here, 2/3 plus 2/6, and also 3/16 plus 5/32. Welcome back. It might be a little surprising to find that two fractions can simply add up to 1. It might be a little difficult to discern as to why. But if we, for example, take 2/3 and turn it into 4/6, if we add that then to 2/6, we get 6/6, which is the same number top and bottom. That simplifies to just 1. Another way in which you could have done it is to simplify the fraction 2/6 down to 1/3, in which case 2/3 plus 1/3 is 3/3. Once again, that simplifies to 1. For the second pair of fractions, 3/16 and 5/32, The least common multiple of 16 and 32 is 32. And all we have to do is double the top and bottom of the first fraction there, so that we have 6 30-seconds plus 5 30-seconds for a total of 11 30-seconds. 11 is prime, and so there's no way that we can reduce that any farther. Sometimes when we're adding fractions, there really is no common factor whatsoever, and so 8 is 2 times 2 times 2, 5 is prime, there's no factors in common to any of those, and so the least common multiple is just going to be 5 times 8, or just 40. That makes it actually a little more straightforward, even though the numbers can sometimes get rather big when we're converting these fractions to 40ths. But it's pretty clear what I should multiply top and bottom of 7/8 in order to get 40ths on the bottom. It's just 5. And so 7 times 5 is 35, and 8 times 5 is 40, so it's going to be 35 40ths on the bottom. What am I going to multiply 3/5 by in order to get 40ths? Well, it's the other denominator, 8. 8 times 3 is 24, 8 times 5 is 40ths. So I'm going to get these two things, multiplying top and bottom here, so that we eventually get 35 40ths plus 24 40ths. I can now add the fractions by adding the numerators, and I get 59 40ths, which can be converted to a mixed number of 1 and 19 40ths. So take a moment to do these two fractions once again. Welcome back. This provides additional practice for the technique that was introduced in the previous slide here. The least common multiple of the two denominators there, 4 and 9, is 36, 4 times 9, which means that we're multiplying top and bottom on the first fraction, 9 and 9, and on the second fraction, 4 and 4, giving us 27 36 plus 32 36. Those add together to form 59 36, which can be converted to a mixed number, 1 and 23 36. For subtracting fractions, the procedure is exactly the same, except for subtraction, of course, of the numerators. So let's take a look at this here. Once again, we need to have a common denominator. In this case, the least common multiple of the two denominators is 8. And so our first fraction is going to remain the same, but our second fraction is going to be converted to 4/8 by multiplying top and bottom by 4. From that we have 5/8 minus 4/8. Well, that's simply 1/8. So you can see here that the process of subtraction is virtually identical to that of addition. Let's take a moment to apply this technique towards the subtraction of those two fractions. Welcome back. You can see that those two fractions are have one that is convertible from 3/8 to 6/16. That subtracted from 9/16 gives us 3/16. So I want you to try and think now of what an appropriate algebraic expression is for describing the subtraction of fractions here. I'm showing you a representation of two fractions with the same denominator c. One has a numerator a, the other one has another numerator b. If we subtract those two fractions together, you've seen from our previous problems that we will retain the denominator c, but what will be on the top? Well, it's a subtracting b, a minus b over c. Again, this is the joy of algebra, being able to describe patterns in relationships in ways that are small, compact, even elegant. And there's an example there with the subtraction of fractions. So let's talk about mixed numbers here. We'll see here that actually the procedure is not all that different from just doing simple fractions here. We have 1 3/10 plus 2 4/10. We can represent that again with pies, 1 3/10 there, and 2 4/10 there. You can see that we can add the whole pies and the fractional pies separately. If we add the whole pies together, we have 3 of them there. If we add the fractional pies together, 3/10 plus 4/10 equals 7/10. So you can probably predict what our answer is going to be. It's going to be 3 7/10. You could also do this, by the way, by simply converting each one of those fractions to an improper fraction. That would be 13/10 plus 24/10. Those would add together, the numerators would add to give you 37/10, which you could then convert back to a mixed number, 3 7/10. Sometimes that's the easier way to do it, in fact, but I also wanted to show you this way as well. Here's another example of this again, but in this case, excuse me, something actually unusual happens. We have 3 3/5, which you can see represented above it, plus 5 3/5, again represented above it. And when we add those together, the whole parts add up to 8, and the fractional parts add up to 6/5. 6/5. Well, that's an improper fraction. It's not really appropriate for that fraction to be next to a whole number in a mixed number. We need to have a proper fraction there next to the whole number. 6/5 is 1 1/5. And so really what we need to do is take the 1 in 1 1/5 and add it to the 8, making it 9. And the result here is 9 1/5. This is similar to when you're adding numbers together and you carry a 1 or carry a 2. Here we're actually carrying a whole pizza, so to speak, because inside 6/5 is one whole pizza, which means that 8 becomes 9. There's 1 left over, 1/5. So Here's an example applied to a bunch of mixed numbers here: 5 2/3, 7 3/8, 4 1/2. Once again, we can split this up here, as I'm doing here, into just the whole numbers, 5, 7, and 4, and then just the fractions, 2/3, 3/8, and 1/2. All of those things are actually being added together here, so we can group them likewise. 5 plus 7 plus 4, that's 16, and for 2/3, 3/8, and 1/2, we have our conundrum, our usual conundrum of finding a common denominator. The least common multiple of those three denominators is 24, which means that we're going to be converting each one of those fractions to 24ths. So you can see here, for the first fraction, we're going to be multiplying top and bottom by 8. The second fraction, we're going to be multiplying top and bottom by 3. And the third one will be multiplying top and bottom by 12. You can see we've added, on the left-hand side there, we've added the whole numbers, 5, 7, and 4, to give us 16. Simplifying those fractions together here, we now have 16 plus 16 24ths plus 9 24ths plus 12 24ths. We can add those fractions together to get 16 plus 37 24ths. Once again, we've got an improper fraction involved here, which we can convert to a mixed number, 1 and 13 24ths. So really what we've got here is 16 plus 1 plus 13 24ths, or 17 and 13 24ths. In a similar fashion, work on adding these three mixed numbers. Welcome back. We can see a very similar sequence of steps here to the problem from the previous slide. 3 plus 7 plus 5, those three whole numbers are being added together to form 15. And we're adding the fractions, 3/4, 3/16, and 7/8. The least common multiple there is 16, so that's our common denominator with which we proceed. 3/4 gets converted to 12/16. 3/16 stays as it is. 7/8 becomes 14/16, and those three fractions add together to give us 29/16. 29/16 can be converted to a mixed number, 1 and 13/16. All of the stuff added together then becomes 16 and 13/16. So, how do we do the subtraction of mixed numbers? Well, once again, as you might guess, it's very similar to the process of similarly subtracting fractions. It's also got some similarities to adding mixed numbers. Let's visualize the pizzas once again, 3 and 7/10 and 2 and 4/10. You can see in this case we can actually just subtract the whole number parts of these. 3 minus 2 equals 1, and 7/10 minus 4/10, that's going to give us 3/10 there. So we can see in this case from the pictures that we just subtract the whole numbers and subtract the fractions. Now you can also, once again, convert each one of those mixed numbers into improper fractions. 37/10 minus 24/10 will give us 13/10. Again, you can convert that 13/10 to 1 and 3/10 and get your answer that way. Sometimes, however, this is an easier methodology to use. And in the same way that sometimes adding mixed numbers involves a kind of carrying, we also have an instance in which we have a kind of borrowing when we're subtracting mixed numbers here. Here we've got 9 and 1/5, and we're subtracting 3 and 3/5. Well, we can subtract those whole numbers, fine, 9 and 3, but when we subtract the fractions, 1/5 minus 3/5, we run into a problem. And that is that 3/5 is larger than 1/5. We can't really do that subtraction. So what we have to do is something similar to the process of borrowing when we subtract numbers. We have to take one of these whole pizzas and actually divide them up so that instead of one whole, it's actually, in this case, 5/5, which means that 9 becomes 8 and 1/5, becomes 6/5. So 8 and 6/5 minus 3 and 3/5 becomes 5 and 3/5. So that borrowing takes place there so that we have, so that we're able to do that subtraction of fractions there. So here's some examples for us to pursue. 15 and 7/8 minus 4 and 1/2. Well, the fractions need to get a common denominator, which, is in this case 8. 15 and 7/8 minus 4 and 4/8. If we subtract the whole numbers, we get 11. If we subtract the fractions, we get 3/8. 18 and a half minus 15 and 3/4. Once again, we've got to get a common denominator on the fractions. 1/2 becomes 2/4. And here we can see an instance in which we have to do some borrowing. 2/4 minus 3/4. We need to borrow from the 18 to make it 17 and add another 4/4 to our fractional part here. So 18 and 2/4 becomes 17 and 6/4. Now we can do the subtraction of both whole numbers and fractions. 17 minus 15 is 2. 6/4 minus 3/4 is 3/4. Lastly, 100 minus 27 and 1/4. Well, this is a fairly obvious example of needing to borrow. We don't have any fractional part on the 100. So an easy way to do this is just to simply borrow 1 from the 100, make it a 99, and turn that 1 whole into 4/4. 99 minus 27 is 72. 4/4 minus 1/4 is 3/4. So you can see here, hopefully, in a repeated sense, the need that we sometimes have for borrowing when we're doing the subtraction of mixed numbers. So making use of these techniques, subtract those 3 pairs of mixed numbers. Welcome back. Well, we can see with the first problem, after we've converted both denominators to 30 seconds, the process of subtraction is actually pretty straightforward. 9 minus 4 is 5. 5 30-seconds minus 4 30-seconds is simply 1 30-second. For the second one, we had to significantly borrow from the 14 to make it 13, and that changed our 1/7 into 8/7, which we could then subtract 3/7 from to get 5/7. 13 minus 12 is 1. Lastly, we had a whole number subtracting a mixed number, in which case we needed to once again borrow to make 843 and 842 and 8/8 minus 115 and 7/8, giving us 727 and 1/8. So you can see here that even when the numbers get large and perhaps intimidating, the rules, the procedures, the processes are exactly the same. Now lastly, here's something I want to show you here. I'm showing you fractions within a fraction rather. On the top, we've got a fraction that has in the denominator a 7, and in the top it's got a mixed number, 2.5. Once again, fractions inside of a fraction. And on the bottom, I'm showing you a fraction that's got a 4 in the numerator, and what does it have in the denominator? 1.5. This can be pretty intimidating until you realize, once again, that fractions are division. And so these large fractions that we're seeing here, 2 and 1/2 over 7, can be simply changed to 2.5 divided by 7. We're dividing two mixed numbers. We've seen this before, where we can translate each of those mixed numbers into fractions. Dividing is simply multiplying by the reciprocal, so that's 5/2 times 1/7. There's no common factors we can cancel top and bottom, so we're just going to multiply across and we get 5/14. On the second one here, 4 divided by 1 and 1/2. That's exactly what that complex fraction is saying there. They're called complex fractions, by the way. 4 divided by 1 and 1/2 simply becomes 4 over 1 divided by 1 and 1/2 is an improper fraction, 3/2. Dividing by something is the same thing as multiplying by its reciprocal, so 4 over 1 times 2/3 is how we can change this. The result is 8/3, which we can convert to a mixed number, 2 and 2/3. So you can see here, actually, there's a lot of familiar stuff that's going on here. It was simply the reinforcement and reinstatement, the confirmation that fractions are division. And when you've got fractions inside of fractions, you can simplify it simply by changing that fractional line to a division symbol. And even if you've got a fraction on top and a fraction on the bottom, then what you have resulting from that is something familiar. So, using those same techniques, simplify that complex fraction. Welcome back. That last step there is actually a mistake. 51/36 becomes 1 in 15/36. That should not be a 16 in the bottom there. That should be a 36. So you can see that, but you can see throughout this process here that it's pretty much the same thing that we were doing in the previous slide there. We've got a mixed number on top, a mixed number on the bottom. Having those things separated on the top and bottom of a fraction just means we're dividing one by the other. 6 3/8 divided by 4 1/2 is 51/8 divided by 9/2. Dividing by something is the same thing as multiplying by its reciprocal, so it's 51/8 times 2/9, which becomes 51/36, or 1 in 15/36. So that's the end of part 2, but what I'd like you to do is to take a look at all that's been covered over not just this video, but also part 1, and ask yourself, as you take a look at the activity sheets that have been used in covering all of this material, what are the things that are most important? I would suggest that the things that are most important that you might want to mark or star or highlight or do something that that really allows it to sparkle out to you when you're looking at it, in particular for studying for an exam. Here's one technique. How do you find the greatest common factor and least common multiple or something? Where is that sitting on your activity sheet? Where can you find that information when you're studying for an exam? Another thing, what are the rules for divisibility? Dividing by 3, dividing by 5, dividing by 4, by 6, by 10. Where are those rules of divisibility stored? Find those and mark those. Equivalent fractions and fraction comparison. How do you compare two fractions, especially when their denominators are different? How do you find two different equivalent fractions, one equivalent fraction from another? Or conversely, how do you take a look at two fractions that you're not sure are equal and test whether or not they're equal? By doing, for example, cross products. Other properties of fractions. What happens when the numerator and the denominator are the same? What happens when a 0 is in the numerator? What happens when a 0 in the denominator? What happens when you have a negative sign both in the numerator and the denominator? What happens when it's just in the numerator or the denominator? There's a place in which we've covered all of that in our videos, and I want to make sure that that's sitting somewhere on your activity sheet, well marked, so that it's available for you to study. In addition, converting between improper fractions and whole or mixed numbers. How do you do that? If someone were to take a look at your activity sheet, would it be clear exactly how to do that? So take some time to look for those things as well. Converting between fractions and decimals. We've done some activities associated with that. Make sure that it's very clear how to do that. Fraction addition, subtraction, multiplication, division. There's actually places in which I've allowed for you to place the formulas that we came up with for describing fraction addition, subtraction, and multiplication. Really, the only thing for division is just knowing that division is the same thing as multiplying by its. Complete that sentence. You should know what that answer is there. And then lastly, mixed number addition and subtraction, and mixed number multiplication and division for that matter as well. So keep those things in mind. Hope this was helpful, and I'll see you in class.